Hello, geometry. It is about the end of your day today. It's almost 2 o'clock. Hopefully I can crank out another video, work out, go to the last soccer game of the year, maybe do another video. Let's see what we got. Alright, here we go. Proof triangles. 2 other formulas here. So far we have side, 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 angle, side. Now, angle, side, angle, and angle, angle, side. And don't forget hypotenuse, leg with right triangles only. So my learning targets, I can prove triangles are congruent by angle, side, angle, and angle, angle, side. And I can solve real life problems using those. Okay, here we go. Yeah, the real life problems actually happens in the homework. So, tell whether the pair of triangles is congruent or not congruent, and why. So first of all, PT bisects QS. Okay, so PT is going to cut QS in half. So that means we have this segment and that segment. Also, this little box tells me I have 2 right triangles. And R is the midpoint of QS. I just said that. PT bisects QS and R is the midpoint of QS. Alright, I guess you don't need that extra statement. Let's see, PT bisects QS. It should say QS bisects PT. I think I should switch those around here. Didn't notice, because I want this segment to be congruent to that one. And that's the case. I have a right triangle, and I will have the hypotenuse leg. Okay? Now what's interesting is, some of you said, well, wait a minute, you have vertical angles. If you have vertical angles, I wouldn't need that statement, and I would have angle, side, angle. So this warm-up could actually lead into today's lesson with angle, side, angle. Alright, I like this activity. It says, draw points A and C, draw a line AC. Okay, so then choose a point B so that BAC is acute. Okay. But you know what? Let's see. Let's start drawing. So I have to draw AC. I'll give myself some space here. So I'll draw towards the lower part. A, C, okay. And choose point B so that BAC is acute. So we want BAC to be a small angle. So I'll put B right here. Okay. Draw a circle with center B so that the circle intersects AC. Alright, let's see here. My little compass here. Is this going to go through it? Yeah. Did you see that? Here we go. So I have my circle. And now let's start connecting. Okay. Okay, so I draw a circle center B so that the circle intersects AC, which I just did. Label the points D and E. I'll put D right here. And E right there. Sorry I didn't use a ruler. Not sure what got over me. What can you tell me about triangle ABD? Okay. I'm going to draw ABD. Okay. And ABE. ABE. Okay, first of all, for ABD and ABE, angle A is the same. AB is the same length. And I know BD and BE are the same length because those are radii. But I have 2 different triangles. Okay, if you have 2 different triangles, you cannot assume that they're congruent. Because they're very different. But I kind of if you see, we have angle, side, side. So that means it does not work. Okay, so what can you tell me? Draw them separately. It makes 2 different triangles. They're not congruent. Okay, because remember, all radii of a circle are congruent. And they both have that angle. And I know that this segment is the same for both of them. So, alright. Postulates and theorems. Here we go. angle, side, angle, and angle, angle, side. So, and angle, angle, side. So if two angles and included side, remember how before when we had side, angle, side, we had the included angle, but now we have the included side, meaning the side is in between the two congruent angles. And then this one, we have angle, angle, side. So angle, angle, side. So these are two different ways that we can find congruent triangles. Okay. Next page. Here we go. Can the triangle be proven congruent? If so, state the postulator theorem. So, let's see here. This one, I have side, angle, side. So yes. How about this one? Angle, angle, angle. No. There's no angle, angle, angle congruence, but it is similar. By angle, angle. And that's a section coming up in the future. How about this one? I have an angle, side, side, but wait. This angle is a right angle, so yes, it is hypotenuse leg. Don't call it side, side angle. How about this one? I have a side angle, angle, or you could say angle, angle, side. You're not used to it yet because I just introduced it today, but how about this one? Side, side, side. Here, side, angle, side. Now, I haven't showed you this one, but this one is true. It's actually leg, leg when you have a right angle, but it's also side, angle, side. So that's why leg, leg is usually not taught, because it does follow through with the side, angle, side. How about this one? Side, angle, angle, or you could call it angle, angle, side. And last but not least, angle, side, side. No. We don't have that in geometry. Okay, let's play with some proofs here. Remember, it's a pretty big proof chapter. Okay, here we go. Given, angle A is congruent to angle Q. Alright, so in the picture we have two arcs here. And so I'm going to put two arcs there. And then B is congruent to R. Let's put one arc there, one arc there. And then AC, that's this segment, is congruent to QP. Okay. Prove that they're congruent. Well, I have angle, angle, side there. I guess you're kind of done. But we can't use angle, angle, side until we prove it. So we have to use old stuff for it. So you ready? Here we go. I'm writing down these two for my given. We'll get back to that. Now, if you know two of the angles are congruent, you know that third angle is congruent. That's right here. Angle C is congruent to angle P. So, third angle theorem. Remember the third angle theorem? If two of the angles of triangles are congruent, then the third angle is congruent. Alright, and then I'm taking that other segment congruency that was in the given portion. Now we can prove that they are congruent by angle, side, angle. So we're basically using this. Okay? Angle, side, angle. So in order to prove angle, angle, side, which we were just introduced today, you actually have to use old stuff to get there. Okay? Next one. This one looks complicated. So it probably is. Here we go. See if we can figure it out. Complete the proof. Okay, I like to look to see what we're trying to prove here. BEA, that's this bottom triangle, is congruent to DFA, this one here. Okay. So, and notice I'm splitting apart the given here. CEA, that's CEA, is congruent to CFA. So this angle is congruent to this one. Then, CEA and BEA are supplementary. So we're looking at this angle right here. And also CFA and DFA are supplementary. So we're looking at these two angles. So Definition of a linear pair. Linear pair, or you could just say linear pairs. Angles that are linear pairs are supplementary. Now, BEA, that's this angle, is congruent to this one. Why? Congruent supplements theorem. If you have two angles that are congruent and the other supplements, then the other supplements are congruent. So, congruent supplements theorem. That doesn't come up a lot, but it's kind of handy. What do we have next? Remember, I'm trying to make this angle congruent to that one. Okay, EA, that's this segment, is congruent to FA. That was a given. Then EAB, that's this angle. I'm going to put an arc with a line in it and denote it congruent to this one. What are those two angles called? Vertical angles. And then, that triangle is not congruent to that one. Why? We have angle, side, angle. Pretty nifty too, huh? Alright, next one. Hopefully I fixed this. Several observers, let's put an O there, along a straight shoreline measure the angle between the shoreline and a parachute of a space capsule that has just returned to Earth. If the distance between each pair of observers are known, how many angle measures are needed to locate the capsule parachute? Well, 2. Why? We know the distance between the two observers. And you've got that parachute. I don't know what it's going to look like. If I know this distance, we have to find these angles. So, alright. So that would be just 2 angles. Not a very fun problem. In case. Moving on. Concept summary. So here are the different triangle congruences that we know. Side, 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 angle, side, angle, angling side, and a right triangle, hypotenuse, leg. I like to call it HL. Okay, so wherever I got this from, they were calling it hypotenuse side, which is okay. Notice that side, side angle is not up there. Please don't use it. All right, let's find out which ones are congruent. Okay, let's see here. We have side, angle, side. Angle, side, side. Nope. Side, angle, side. Angle, side, side. Okay, there seems to be a pattern here. Side, side, side. Side, side, side. And this looks like a right angle, but we don't know. It doesn't have that box there, but I do know this segment right here, so this will be side, side, side. Let's go to number 8. Side, angle, side. Angle, angle, side. Right angle, so this will be a hypotenuse leg. This one, none. We just have hypotenuse. I don't know anything about the other sides. Hypotenuse leg. I know this angle, so that means I have a side, angle, side. I also know this angle, so angle, side, angle. I know the reflexive side here, so side, side, side. I know this reflexive side, so I have side, angle, side. Alright, this one's tricky. You have this symbol's telling us parallel lines. Okay, so if number 17, if this is a parallel line, I'm going to extend them a little bit. Cut by a transversal, I know that this angle is congruent to this one. And then I also have this reflexive side, so I have a side, angle, side. Pretty tricky, huh? Hoo hoo hoo. And it's only because I had the parallel line symbol in there. Same thing. But now I have, let's see here, angle, side, side. Nope, doesn't help. Let's see here. Now look, 2 sets of parallel lines. Okay, so if you have 2 sets of parallel lines, I know that this angle is congruent to this one. you know, if I extended these. But if I extended this, I also have this angle. Congruent to, oops, I messed that up. There, I fixed it. This angle's congruent to this one, this angle's congruent to that one, and then reflexive side. So I have an angle, side angle. So you've got to pay attention to those parallel lines. How about this one? We don't know anything about the angles. So, however, I do know that this is an isosceles triangle. And we haven't learned this yet, but isosceles triangle will have congruent base angles. Okay, so if this isosceles is congruent to that one, I know what base angles are. So that means I could have an angle, angle, side. So, but we don't know that yet. So in this case, we'd probably say none until we learn more about the isosceles triangles. Okay, but let's write that down. So you see, in the future, we're going to be learning. We're going to be picking up some of the stuff that we had before and applying it. This one we definitely have side, angle, side. Our vertical angles tells me angle, side, side. Nope, not enough. Okay, now if I split this one apart, this is a common symbol right here, okay? So I'll have a side, angle, side. Same with this one. If I split it apart, I'll have an angle, side, angle. And this one, it has a common side. It's not enough. Okay, so we have a common side, but it's not enough. Here's our homework, Common Core Standard. Everybody have a nice afternoon.